And because lots of people work in the areas where you have worked, you get lots of work in those areas, so it will be really great to hear from you. So, so today we have Dr. Baldev Gulati sir. He is director at NIA and Nivedi, Bangalore. He did his bachelor's from Haryana Agriculture University, Hisar, and then master's and PhD in microbiology from there. He worked as a postdoctoral associate at University of Minnesota, USA, between 2000 and 2001. And then he also worked as an associate professor at the veterinary in veterinary microbiology at Haryana Agriculture University, Hisar. And during that time he has worked on various animal diseases like rotaviruses, Japanese encephalitis, equine herpes viruses, and isolation and characterization of equine mesenchymal stem cells. So, and currently he is heading the new institute, which is one of the premier institute for disease investigation, forecasting, epidemiology. So a lot to hear from you, sir. Please, you are most welcome. Please deliver your talk.
Good afternoon. At the outset, I would like to say Happy Veterinary Day 2023. And I would like to thank National Institute of Animal Biotechnology for giving me the opportunity to interact with you people and on this auspicious day. And especially I would like to thank the director of NIAB, Dr. Taru Sharma ji. She was very much persistent that I have to be here, and it is in fact an opportunity for me to talk with the scientists and fellows, colleagues of this place. So, dear friends, World Veterinary Day is being celebrated for last about since 2008 or so, and every year there is one theme. So this year we have the theme promoting diversity, equity, and inclusiveness in the veterinary profession. So when we talk about diversity, I understand that in veterinary profession, we should have people from all religions, all castes, all creeds, or all gender, and we should have the equality and no discrimination based on the religion, the gender, or if you are coming from lower communities, there is no such kind of discrimination in veterinary profession, and we are providing justice to the all stakeholders, including the livestock owners, the farmers, the animals, and we are promoting this inclusiveness of one and all in this veterinary profession. So this is what I see that NIAB, I find they are already on to this theme. They are promoting the diversity, equity, and inclusiveness. On this occasion, what I will be talking about is emerging infectious animal diseases in India and mitigation strategies and the role ICR Nivedi is playing in that sense. I was told by the director, madam, that my focus should be to talk about what Nivedi is doing and how Nivedi and NIAB can collaborate. So with that emphasis, I'll be just introducing the topic and talking about what is the purpose of Nivedi and what are the activities Nivedi is doing. And subsequently, we can talk about how we can collaborate and cooperate and coordinate like you are doing One Health. We between the Nivedi and NIAB, we can have one veterinary health. That kind of collaborations we can think of working. Okay. How is it going? It's back. Yeah. So world over, we are facing challenges of infectious diseases, and India is also one of the countries which is the most hit by the infectious diseases, and last decade has been the most challenging. We have seen the emergence of many transboundary animal diseases, including zoonotic diseases, like we saw the CCHF 2011 that came into India, then porcine reproductive respiratory syndrome 2013, it caused havoc in the pig industry. Then 2019, lumpy skin disease came. We are still, the livestock sector, the cattle industry is still suffering because of lumpy skin disease. 2020, again, another important pig disease came, African swine fever. And also we face the COVID-19, which is again is thought to be a animal origin disease, which has caused the greatest of the pandemic world over in the human population. And then 2021, we faced another disease called monkeypox. So why these diseases are coming again and again, and what are the reasons and how we have managed, or rather I would say we failed to manage these diseases because of our inadequate capabilities and inadequate interventions for infection prevention control. The response system has not been adequate. Rather, I would say that we were just witnessing the diseases coming in the country, entering into a boundary area through some port, and then we are seeing that disease is spreading with not much significant interventions. So this is what is we call as we failed to do the risk assessment. When I say risk assessment means before the event occurs, before the disease enters into your country or into your territory, you do the assessment. How much is the likelihood of the event occurring, the hazard occurring in the country, And based on that assessment, we should be doing the preparedness to prevent or to minimize the damage caused. We are not doing the risk assessment prior to the occurrence of event. We will be taking some uh, measures like if this boulders start rolling down the hill, we'll have to run immediately. So this is what exactly we have done, whether it was COVID-19 or whether it was lumpy skin disease or whether it has been African swine fever. This is what I will be talking in my subsequent presentation. So coming back to the risk assessment, uh, we have to identify what are the transboundary animal diseases or transboundary zoonotic diseases where we are at the risk of, and then what is the extent of that risk assessment. We must be telling, is it the significant risk, most probability or less probability, and then identify and quantify risk estimation. That is one part. When we have done that, and if we have done that before the occurrence of the event, we can think of, if it is significant problem, we can think of risk management, and also we communicate to the different stakeholders for management and prevention of the risk. So this is where the institutes like National Institute of Veterinary Epidemiology and Disease Informatics are meant for the estimation of the risk of the diseases, and then estimation of how much is the extent of the risk, and then we have supposed to communicate with our stakeholders so that they are prepared in real time before the event occurs to mitigate such a risk. So with that, the Nivedi was established. We started working from 2000 in the form of just one research project. And at that time, there was animals in India were suffering with the great plague, which we call as rinderpest. So Nivedi played significant role in getting eradicated the rinderpest from the country. And based on that recognition, based on that contribution, this one research project, which we call as All India Coordinated Research Project, was converted into an institute in 2013, which we call as National Institute of Veterinary Epidemiology and Disease Informatics. Our main mandate is working on epidemiology, informatics, and economics of animal diseases, including zoonosis. And we also work on surveillance, forecasting, and forewarning for management of animal diseases. And we also work on the development of a repository for these purposes, as well as the capacity development of the country in these areas. So these are our activities or the mandates we are doing. And this one slide will be summing up what exactly we are doing at Nivedi. So we are working on capturing the disease data from the entire country. We capture the data with the help of state veterinary departments. We have a network of collaborations with all the states of the country, 28 or 29 states plus few more. So we have 31 collaborators. They are giving us the data of disease every month. On monthly basis, we are getting the data from them. We call those network as a National Animal Disease Epidemiology Network. So these centers, they help us providing data. Then we also get the disease inputs from various sources like publication, whether it is social media or maybe research publications. And then we also go for surveillance in the field. We go for outbreak investigation. We go for epidemiological investigations. And then we also go for micro surveillance. So from various sources, we are getting the data of livestock diseases. Previously, we were getting the data of around 13 different livestock diseases. Now we are adding as and as the new diseases are coming, emerging, we have started capturing data for the more diseases. So far, we have the data of these 13 diseases for last 20 years. The data is available with us. So we are getting on monthly basis data, how many animals got diseased, how many animals got vaccinated, how many animals were seropositive, the lab-based data also we are getting. Then we are also getting for certain diseases, the data on, we are getting samples from them, animals from, we make the sampling plans, we give to each state, they implement based on those sampling plan, we identify from this village, this district, this town, you have to collect this much sample from this animal. That kind of information we give to them, so they return us those samples, we test them, and based on that also we find the effectiveness of the various disease control programs that I will be talking in subsequently. So once we have this kind of data, we start playing with that data. I was talking the other day with Dr. Saab sitting here, that you are also working on some kind of disease informatics and other informatics tech tools. So we do say some kind of spatial endemicity. We work out in which district, entire country, which taluka, which village, what is the endemicity of the disease, spatial as well as temporal. And then we also do the space-time clustering, linear discriminant analysis, risk modeling. We make the risk maps, hot maps, cold maps, and this kind of activities we do with that kind of that data we are procuring from different sources. So as I was saying that we have the collaborators in the entire country, which are providing us the information about the disease. It is different when you are working on a disease on an animal, and it is different when you are working on a disease in a population. So Nivedi is not working on disease in one animal, but Nivedi is working in disease in the entire population, in the entire country. So with that, we have to depend upon our collaborators throughout the country. We have almost 31 collaborators, which we are now expanding to 40 from this year. So these collaborators, they support animal disease epidemiology and informatics by collecting, generating, and collating livestock disease data and systematic outbreak investigation. So every state animal husbandry department, they have a setup of veterinarians and the para-veterinarians. They are working at district level and taluka level and village level. They collect information about the disease. They do the seroepidemiological studies they do, and they provide us the data. With that data, as I said in previous slide, we do the analysis for risk mapping, epidemiological trends for warning, and communication for taking appropriate interventions. And then we also devise epidemiological solutions for effective control of animal diseases. I will be taking one or two examples of disease as case studies so that you can understand what role we play in disease management or disease control in my subsequent slides. So we not only get the disease data, we also collect the data of all the risk factors associated with the disease. Maybe, for example, host associated factors, what is the population density, what is the animal traits which are contributing to the disease burden, whether there is previous exposure or national status, general health. Similarly, we are also getting information on agent related factors, which is the virus, bacteria involved, what are their genotypes, phenotypes, serotypes, and whether it is virulent, most virulent, whether there is vaccine available or vaccination done or not. This kind of information we are getting about the agent factor. Then environment and management factors also we collect the information about the disease, like what is the temperature, what is the humidity, what is the radiation, perception, precipitation, air movement, and monsoon movement. this weather information also we are collecting, meteorological data also we collect. Then we also have the data at village level about the livestock population. This is just the data I'm showing of census, but we have the data in each village, how many animals are there, how many cows, how many buffaloes, how many sheep, goat, that kind of information. Then we also are getting on real time mode the remote sensing data on different parameters listed here. And also we are getting real time data on meteorological parameters like this temperature, rainfall, humidities, and so many meteorological parameters. So we have on one aspect, one side, the data about the disease. On the other side, we have the data about the risk factors. On the third side, we have the data of the livestock population density. Then we have the remote sensing and meteorological data. When you have these much of data, if you collate these data, you can make a prediction, you can make forecasting, you can make more warning. So this is what we are doing. We are procuring data, as I explained earlier, inputs about the disease data coming from different sources, including the risk factors, the climatic risk factors, non-climatic risk factors, vector abundance, or many other environmental factors we are collecting from different sources. We clean up that data. Sometimes it is not that whatever data we are getting is entirely to be fed into the system for analytics part. We have to sometimes go for cleaning, annotation. We do that kind of activities. And for that, we empower artificial intelligence and machine learning tools for playing with that data, using different algorithms of disease modeling. And then we go for the whatever models we are using. We have different disease modeling algorithms. We see for which disease which model is best fit, and then we go for the assessment of the model and go for the based on these inputs from various sources. We give the results in the form of predictions, in the form of hotspot maps, in the form of forewarnings or risk maps, and also we communicate risk to different stakeholders in the form of bulletins or mobile apps using alert messages or web portal. Our web portal also we have where this information can be accessed by anybody, so that we can communicate to our stakeholders for taking appropriate measures so that disease predicted by us does not occur. The event risk predicted by the Nivedi does not occur. We go for the validation of this data also. We predicted, say, for example, what we are doing is we tell 2 months in advance to all our stakeholders, to the entire country, at their district or at their taluka. Currently, we are more working on district level. We are trying to shift it to the village level. We are communicating risk of, say, for example, anthrax. We predict that today is April. So we have already predicted what is the risk of anthrax in a particular district in Telangana in June. It is already predicted, and every month before 10th of that month, we communicate the risk for the 2 months in advance. So that they have sufficient time, they can take interventions. Based on those interventions, then when June will be coming, we will be again getting the June data that will be validating our predictions. Say if we make 100 predictions of risk, it should not be more than 100 cases occurring. It should be something less, maybe 20 or 10 or 40, because some interventions are occurring. So that kind of validation. Yes, please. Yes, I will coming to that. Then there are mathematical modelings. Now, like you saw in COVID-19, we were predicting the disease, but we had data only of maybe 1 year or 6 months. There were people biostatistician or computer scientists. They were working with different mathematic modelings based on the if we get even one case, we can, and we get the other information related, as I said, all the risk factors. Based on that, you can make mathematical calculations and make the predictions. Of course, your accuracy of prediction will be better as you have the longer duration of data with you. Like I said, we have for 20 diseases, 13 diseases, we have data of 20 years. And we have the data of all the 20 years weather, for meteorological data with us, GIS data with us. So our predictions for those 13 diseases far better than what we are going to predict for lumpy skin disease or African swine fever. So as you keep on working on a disease, your accuracy improves. Baseline data of disease, when it is a new disease, yes, if it is there, if it is not there, even then, if you have baseline information of a disease, like I said, lumpy skin disease, I will be talking. 2019, when first disease came, first case from somewhere in Orissa, some district of Orissa, I will be talking about that. When the first case came, Nivedi make the predictions based on all the information available about the lumpy skin disease, its transmission patterns, its vectors, and its climatic factors. We made a prediction that this disease is likely to spread, and we gave the warnings that we have to take the emergency measures. Unfortunately, because it was in Orissa and it was just somewhere in August, September 2019, and that season, I will be talking about that. That season, it did not spread to beyond Orissa. So we relaxed, and that this is not serious consequences. We did not take necessary measures. So what was the consequences? That 2019-20 went smoothly. 21 also partly went smoothly. After that, it became a serious problem by 2022. It is not disease like COVID-19 which spread so fast like fire. It is like influenza or some other diseases which spread very fast. It is a vector-borne disease. It cannot spread very fast. But it was our laxity. It was our laxity, I would say, that despite being alerts, we did not take measures to prevent it. So if there is limited data also, if you have not data of your country, your boundary, you have your neighboring countries data, information. We were getting lumpy skin disease is spreading from 2017 onward. 18 we came to know it has come to somewhere in China, Bangladesh. So that is a good data. It does not come straight away from Africa. It is coming to India, although there are possibilities there also. But we were getting the informations, and based on that information, we make the predictions. Mm-hmm. But making prediction based, that is why I say we are working disease in a population, not disease in an animal. If I have to say this animal, this cattle is positive or not, I have to test. But when I have to say whether disease is there in population, that is a different question. So let us not. That's why in the beginning I said, not be thinking of one animal, thinking of the population of 300 million cattle. 300 million cattle, where 192 cows and 110 million buffalo, something like that. So look at that population. Mhm. That's what I showed you. This information is based on so many sources and so many points. We are also getting the disease case reports data, outbreak data, case reports, outbreaks. Then we are also implementing outbreak investigations. We are also implementing epidemiological investigations. We are also getting the serum samples. We execute the sampling plans. We give to the state, I said earlier, we make the sampling frame for each disease and give it to the implementing agency. That sampling frame, that contribution of Nivedi is really very useful. And I find it that every state, and even the Department of Animal Husbandry, Dairying, Government of India is dependent on Nivedi for our sampling plans, for implementing their control programs. There are so many control programs going on. 2019, we launched a control program for brucellosis and FMD. Prime Minister of India launched that program 2019. 13,413 crore rupees amount has been uh, given for that these two diseases alone. And for implementing that control program, all strategic planning is done by this institute, Nivedi. And not only we did the planning, we are also giving them midterm corrections also sometimes. You are not, sometimes we said that vaccination should be done this way, and vaccine company was not available to provide the vaccine. So then we had to do the midterm correction. So based on our inputs, Government of India has made the target by 2030, these two diseases will be eradicated.
So the population, they don't know about the disease. Completely. Based on those kind of data also collected and they will be inserted in your prediction tools.
That's true. That's true. Every kind of data is, say, for example, sometime novel disease, as you are saying, is coming in the country. Disease never comes as a single case. It comes as a cluster. So when from a village we get some unusual alerts, there is some cattle में कुछ problem है, there are some lumps on their skin, and one village, then another village adjoining. So this is just a good alert. It is just a good alert so that we send rapid response teams there. They collect the samples, they collect the epidemiological information. Disease diagnosis just not depends only on sample testing. It also depends on epidemiological information. Pattern of epidemiological of disease can be good enough to confirm which infectious disease is this one. So that is one thing. When these kind of alerts come, rapid response team go there, they collect the samples. Then role of institutes like NIAB is also there, rapid diagnostic for laboratory confirmation of the disease. All right. Yes. Mm-hmm. 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 Definitely, these tools are being applied, AI and machine learning. Today, I was talking, there was one person, he has made AI and ML tools, muzzle, based on the muzzle image, he can identify the animal, specific animal. This animal is that breed and that it belongs to this person. like we are doing through our biometrics. So, but because Nivedi's mandate is only on disease epidemiology and disease informatics, we are not using those today. So we just working on focus mandate, and that is a big mandate. That we have with the क्या नाम है, meteorological departments, remote sensing department, they provide us real time. और net से download हो जाता है, हमें link मिला हुआ है, immediately मिल जाता है. Every day we can download that data. Yes, yes, it is available, and they are free of cost also. So I was saying that based on all those data inputs, we go for AI and machine learning. We apply different disease modeling algorithms. Some of them are listed here, and then we work on using different indices like these statistical indices for the data analytics. This is called the predictive data analytics. So these kind of algorithms help us in making the predictions and alerts. So for that, we also have one web-based and GIS support app. This web portal. This is anybody can access here. And when I said this app is working for 13 important livestock diseases, you can find for any district of India at any time. You can. It is open as there is no user required, user or password required. Just log into this website, and you can get the data of say your district and what are the risk alerts, what were the outbreaks occurred, and what is the likely that next 2 months what is going to happen in terms of livestock diseases. So this is whatever data analysis we are doing that can be assessed from this place. So this is what is the kind of outputs come. We make the maps of different livestock diseases, real-time maps, monthly maps, or maybe we can have the annual maps. What was the incidence of disease in any particular district? Just click of the button, we can get the data immediately. And we also have the this kind of maps for 2 months in advance of risk of those 13 livestock diseases. For example, this map is showing the serosurveillance of bovine leptospirosis. This is the data of say 1 year, and this is showing say, brucellosis. So this kind of information we can generate for whatever data we are feeding, and then once we create the risk, we communicate to all our stakeholders. It goes to the Department of Animal Husbandry, Dairying Government of India. It goes to all state animal husbandry departments, and they have the report with them every 10th of the month, and so that they can see what diseases are going to occur in their territory in next 2 months. And not only that, now we have started communicating these risks to all the state veterinarians through mobile alerts. And in the state of Karnataka, we are also communicating these alerts to the livestock farmers. So this slide is showing just this communication. They have one app. Karnataka government has one app for the farmers. They call it Fruits. So that through that app, we are communicating risks to the livestock farmer. Sheep farmer will be getting alerts about the sheep. The bovine or cattle farmer will be getting the alerts about the cattle. Every month we are communicating. And this is what he is showing last 6 months, how from June to November, how many alerts we communicated to the different farmers. So in addition to, as you said, diagnostics are also required. We are also working on development of population diagnostic assays for diagnosis of many livestock diseases. Some of them are listed here: brucellosis, leptospirosis, blue tongue, and FMD, and many more that we are also developing. And this is the area where Nivedi and NIAB can collaborate for more livestock diseases, the emerging livestock threats. We can have the emergency preparedness also for many diseases. So one more activity that we estimate the burden of livestock diseases. How much is this disease going to cost to the country, so that our policymakers, they can, based on the burden of the disease, they can allocate resources for their prevention and control. Because we were doing this for brucellosis and FMD regularly. Based on our input, we gave them the data how much FMD is costing to the country. They launched the program in 2019 for control of brucellosis and FMD, as I said, and government allocated more than 13,000 crore rupees for these two diseases alone. For example, we estimated the FMD cost 20,896 crore in 1 year. Similarly, PPR, another sheep and goat disease, 1,611 crore. Similarly, for HS, 72 crore, goat pox, 165 crore. And now we are working on lumpy skin disease, how much it is costing, or it's costed during last 3 years. I will be presenting that data in my subsequent slides. Coming back to I said I will be presenting 1 or 2 case studies so that you understand how we move. The lumpy skin disease outbreak in India, as every one of you know, this came in 2019. Whenever a new disease comes, or whenever you have to work on a disease as a veterinarian, when you are going to play a role in epidemiology or disease diagnosis, you must be knowing first the case definition of disease. So this is what Nivedi also plays role in defining case definition of each disease for the Department of Animal Husbandry, Dairying, Government of India. So case definition, when we talk whether it is a human disease or animal disease, we talk for the field worker, how will be they suspecting for lumpy skin disease, and when this case will be called probable case, or when this case will be called confirmed case. So this is what we gave the definition for lumpy skin disease, and it can be any cattle with these symptoms, and with the development of nodules as shown in the picture, can be a suspect for lumpy skin disease, and it can be confirmed if it meets the clinical case definition and confirmed by laboratory testing. So this is one area we are doing. And lumpy skin disease, if some of you are not aware of, it is a pox viral disease. It belongs to the Capripox genus of the Poxviridae family, where cowpox, sheep pox, goat pox, and lumpy skin disease, and buffalo pox, they all come into the same group. They are orthopox viruses, Capripox viruses. So they are transmitted by vectors, hematophagous flies, and they can also be transported through infected animals to long distance. For short distances, vectors are playing role, and direct contact between the animals also play a role in transmission of disease. For long, as I said, it is not like COVID-19 or influenza, which spread like fire, and from one place to another place, it can go in 3, 4, 5 days. It takes time. Lumpy skin disease is vector-borne disease, and vectors cannot go beyond a certain territory of few kilometers. So it took time from 2019 to say 2022 to cause a serious havoc in south of India. So it causes typical pathology, gunshot wounds in respiratory system, and pneumonic lesions on lungs, in addition to what we find the lumps on the skin. Coming to the epidemiology of lumpy skin disease, whenever you are talking of disease, when it is in one animal, fine. But when we are talking of the disease in a population, you have to look at this triad: the host factors, the environmental factors, and agent factors, which are playing the role in the occurrence of the disease. So host factors for lumpy skin disease, we found cattle was more susceptible than buffaloes. Exotic cattle were more susceptible, but disease was less in exotic cattle as compared to indigenous cattle. A reason being exotic cattle were well fed, they had better immune system, whereas the indigenous cattle were in some goshalas or in such localities they were more suffering, and young animals were more susceptible. Crossbred animals were more susceptible. Coming to the environmental factors, virus is inactivated by heat, acidic pH, alkaline pH, so little susceptible. So it it uh, it also depends upon the rainfall, because it is transmitted through vectors which are abundant when the rainfall is there. After the monsoon, I will be showing the data. When vector abundance is there, the disease spread is more as compared to the other month, lean month. When monsoon season is over, after that disease curve starts going down. And then 35 hematobia flies and many tick species, they are involved in transmission of lumpy skin disease, and we have tested many tick species positive by PCR. Many flies also positive for lumpy skin disease. Then coming to this agent factors, Capripox virus is quite a stable virus. Immunologically also it is a stable virus, single serotype. There are no much of antigenic variation like we find in foot and mouth disease, or we found in avian influenza or other viruses. It is quite a stable virus. Why I'm talking this? Because this information is important for control programs. And it is virus is remaining in blood of the infected animal for 16 days. Skin nodules up to 39 days. Scabs, it can stay for years. So animal is shedding scabs in the environment. They can remain infected for several years, and even semen of the bulls carrying the virus for up to 42 days, that has been seen. So why this information is important? When we start talking about controlling or eradicating lumpy skin disease, we will have to see how much virus load is there in the environment, or maybe environmental surveillance will be an important thing. And these will be niches where we'll be looking for the virus presence so that we can eradicate the disease. So lumpy skin disease, I said you need not have the disease in the country to make predictive analysis. Somebody was saying, how can you predict? So when you have in your neighboring countries disease occurring, the Russia disease occur in 2019 May, then it came to Israel maybe June 2019, then it came to Israel and Russia 2000 July 19, it was reported from there, and China, India, and Russia. Disease was reported somewhere in August 19. So you see, India first case reported on 12 August 2019 in Mayurbhanj district of Odisha. This is the state where this first case was reported, and then it started spreading to other countries also. January 21, it reached to Sri Lanka. April 21, it reached to Taiwan, Thailand, Vietnam. May 21 reached to Laos, then Malaysia, Cambodia, August, Nepal, then September, Mongolia. So disease has been spreading. Otherwise, this disease is the disease of African continent only. So it has been spreading. And in India, question comes where it came from. Obviously, China was the one country which was preceding outbreaks in India. China and Bangladesh, they reported lumpy skin disease before it occurred in India. So it is likely that disease came from China either through Nepal or through Bangladesh, and it entered into India in August 2019. And when these isolate from India, lumpy skin disease isolate, when they were compared with these Chinese sequences or the Bangladesh sequences, they were all identical, and they matched with the Kenyan field strain. So virus is moving from Kenya, coming through China, Mongolia, or Bangladesh, or Nepal into India. the same virus. Reporting and occurrence is two things. Reporting and occurrence is two things. So when it is reported from somewhere, people get alert. It might be occurring somewhere. Even in we suspect that disease was there in Nepal also before it came into India. It was there in Bangladesh. It was there in China. It was already reported. 2018 they started having cases in China, but they reported somewhere in March or May 2019. So disease was there, but reporting, when I say reported, I mean it is officially reported. So now, what is the population at risk for this lumpy skin disease in India? I said 192.5 million cattle and buffalo 109. Almost 300 million population was at risk for lumpy skin disease. It is a Capripox virus. It is specific, species specific, affecting only the bovine. But it yes, it gives cross protection. What we did at that time when the disease came, there was one question: what should we do? DSD and the government of India struggling. What should we do? We did not have any vaccine for this lumpy skin disease, although some countries have vaccine, but we were not able to get that. So we had at that time goat pox vaccine. Goat pox vaccine we had, chickenpox vaccine we had. The data from both these vaccines was compared, and it was decided that goat pox would be more appropriate. One thing is that 3-4 companies are already producing goat pox vaccine, and we started doing that. It gave protection, but it was not 100% protection, maybe 70% protection if it gives. And if we give the zero conversion of maybe herd immunity develop maybe 70%, 80%, it breaks the virus chain. Na? So to me, it is not important that one animal disease is to be controlled. It has to be controlled in the population. If we put in some measures, goat pox vaccination, now we have the data. We have compared goat pox and lumpy skin disease. We have also developed the lumpy skin disease vaccine in India. Commercial also launched now by this BioVet. They have already got their approval. Yeah, they are scaling up it. But so far, goat pox vaccination has been done, and comparison between the goat pox and the lumpy skin disease vaccination has also been done. Yes. Mm-hmm. Mm-hmm. No, it has been reported from buffalo also, but extent was not that. It was, say, if 100 cases are occurring in 100 cattle herd, buffalo 1 case. We have isolated virus from buffalo also. It's breed resistance, maybe. This is where the NIAV should be looking for. What is the genetic resistance, genetic basis of this resistance between buffalo and cows? What is the basis of this resistance? We should be looking for that. That yes, even camel we had sporadic cases, but it did not spread in camel. It did not spread in buffaloes. So even now, government of India has decided that let us not go for vaccination in buffaloes. Although at that time we went for goat pox vaccination in buffaloes also. Buffalo, we don't have exotic blood, na, but cows we have. That's what it's like. Crossbred are more susceptible. Crossbred are more susceptible. Lumpy skin, yes, they were, and in fact, indigenous cattle which are kept in low producing indigenous cattle which are kept in goshalas or allowed in the streets, they were more at risk. one thing is they are not getting good nutrition. Yeah, that could be factor. And then their keeping condition, their housing is also not perfect. Crossbred animal को जो 20 लीटर दूध दे रहा है, उसको ओनर भी बड़ा संभाल के अच्छा सा न्यूट्रिशन देता है, साफ सुथरा रखता है, नहलाता है. जो जो दूध 1 लीटर कर देता है, उसको छोड़ देता है सड़क पे, और वो फिर गौशालाओं में जाती है जहाँ पे कि आपको आइडियल कंडीशंस नहीं मिलती हैं. एंड दैट इज द environment where disease incubations take place. We gave the alert to the government of India before the first case was reported from India. We gave the alert that we should be prepared, lumpy skin disease is going to happen. But you know, that is recorded. We have given the alert. The first case came somewhere in August, March 2019 में हमने alert दे दिया था. हाँ. हमने जब ये एंडेमिक थी डिसीज में, उस टाइम प्रिडिक्शन करने का पर्पज नहीं था, उस टाइम तो सिर्फ कंट्रोल करने का था. नाउ वी आर डूइंग दैट. अब जब डिसीज कंट्रोल में अंडर चेक है, एंड निवेदी विल बी वर्किंग फॉर दिस डिसीज टिल इट इज इरेडिकेटेड. अभी आगे चलते हैं, इस पे बात करते हैं. So this is the status of the disease so far. Year 2019 first case reported, and during that time the first case when it was reported, and after that 2019 and 2019 to 2020 the disease was that we call it a first wave. आजकल कोविड के नाम से वेव आने लगी ना, तो लंपी स्किन का भी हमने फर्स्ट वेव कह दिया, although it is not an appropriate term. At that time, although there was high morbidity, cases were there, but deaths were minimum, less than 1%, 0.05%. And disease was only in skin form, only dermatitis, the skin nodules were there. It was not going into the systemic form. Year 19 to 21, 2 years, which we call a second wave, again morbidity was there and mortality increased. Here it was less than 1%. Here we found up to 2 to 3%, 2%. And we were also getting, in addition to the dermatitis, the respiratory form of the disease. Means virus is going into the lungs, causing pneumonia, as I showed the picture, gunshot wounds, that kind of symptom. And year 2022 was the worst case scenario, where the disease was in the entire country, and this was high morbidity and high mortality. Mortality up to 10%. 10% of the cattle, affected cattle were dying because of the lumpy skin disease. And disease was generalized. स्किन पे भी नोड्यूल्स हैं, कहीं भी देखो अंदर हर जगह पे वायरस मिल रहा था. Every tissue there was virus. So yes. Not affected. Mm-hmm. 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 Madam, I would say it was not affected. It does not spread that fast. Yeah. So it was, अगर होती डिसीज तो मीडिया वाले भी आजकल छोड़ते नहीं है. एक गाय भी मरती है तो तुरंत न्यूज बन जाता है. कहीं ना कहीं सोशल मीडिया, हम वो भी ट्रैक करते हैं. सोशल मीडिया, पब्लिकेशन, प्रिंट, वी ट्रैक एवरीथिंग, ताकि अनऑफिशियल सोर्सेज को भी हम टैप करें, ताकि डिसीज मिस ना हो जाए. Mm-hmm. Mm-hmm. Any disease. That's true. That's true. That's very. I said in the beginning कि ये हमारी तरफ से गवर्नमेंट ऑफ इंडिया से लेकर, निवेदी से लेकर, स्टेट एनिमल हस्बेंड्री डिपार्टमेंट की तरफ से क्रिमिनल ऑफेंस है मेरे हिसाब से. आई अंडरस्टैंड कि हम बीमारी को फैलते हुए देख रहे हैं और कुछ इंटरवेंशन नहीं कर पा रहे हैं. तो वो फिर ये हमारा एग्जिस्टेंस का पर्पस क्या है? आज वर्ल्ड वेटनरी डे पे मैं ये कह सकता हूँ, अगर मेरे को दिख रहा है कि सामने बीमारी कैटल को मार रही है और हम कुछ नहीं कर रहे हैं, तो वर्ल्ड वेटनरी डे पे हमारे को एक शर्मनाक स्थिति पैदा होती है। Madam, we did this for COVID-19. Why we should not be doing it for lumpy skin disease? हमें उस टाइम पे जब पहला केस आया था, वहीं पर ही रिंग वैक्सीनेशन कर देते और इम्पोर्टेड वैक्सीन मंगवा लेते और लगा देते। वो मतलब 50,000, 2 लाख, 5 लाख डोजेज से काम चल जाता। और हमने ये डिसीजन करने में, शुड वी गो फॉर गोट पॉक्स वैक्सीनेशन, वी टुक ऑलमोस्ट 9 to 10 months। हम ये डिस्कशन करते रहे क्या लें या नहीं करें, करें तो कितनी डोज लगाएं, 3 लगाएं या 3.5 TCID50 लगाएं। तो ये डिसाइड करने में हमें 10 महीने से ज्यादा टाइम लग गया। तो ये स्लोनेस जो है ना, वो इट किल्स द एनिमल्स। सो डिसीज स्प्रेड to the entire country, and 29,26,000 and something death case reports. This is the data that I collected sometime in month of December, January, December 22. This includes the data up to 22. And this is also the data that we get from all sources. I said we have 31 different partners. They are providing us monthly basis data. So lumpy skin may minimum 29,26,000 cattle were affected, but I still believe that it was more than that. Yes, we have reported this. This data was from 27 states. 27 state का data है ये, जहाँ पे lumpy skin disease को occurrence हुई है, 27 states. You will find here also Rajasthan, bottom of the table. Rajasthan reported maximum mortality. I have visited many farms in Rajasthan where at up to 10% mortality we found. This is what we are talking ना, risk factors जितने भी है ना, सब प्ले करते हैं। वो जो एपिडेमियोलॉजिकल ट्रायड दिखाया था आपको, वो सब मिलके ही बीमारी बनती है, सिर्फ पैथोजन से नहीं बनती है। So this is not for 24, 27 states. I'm sorry, typing error. So 335 districts data. Bovine population 24 lakh 45 24. This is the population, susceptible population, and this was the affected with the lumpy skin, 29,26,039, and more than 1.5 lakh mortal deaths are recorded because of lumpy skin disease. वायरस टेम्परेचर में भी सही चल रहा है, स्कैब में आपका एनवायरनमेंट में आ गया, मैंने कहा सालों पड़ा रहेगा, चाहे गर्मी हो चाहे सर्दी हो। स्कैब के इन्फेक्टेड स्कैब्स, they carry the virus for years. Then there are so many vectors, pathogens which have multiple niches to survive. उनको कंट्रोल करना मुश्किल हो जाता है। अगर मल्टीपल होस्ट हो जाए तो और भी प्रॉब्लम हो जाती है। फॉर्चुनेटली यस, एडिशनल, या that is important. I will be talking about the Karnataka data after this, कि ये जो डिसीज की आउटकम है ना, हमारे कंट्रोल मेजर्स पे भी डिपेंड करती है। कर्नाटका में वैक्सीन डिसीज फैल रही थी, then they 2 districts they were slow in vaccination, and they were the hot centers of the lumpy skin disease. I will be showing that data. So year wise, year 1, this is attacks and deaths. 22 has been the worst case. We had the maximum death here, more than 1,30,000 deaths reported. It might be more than that, maybe 30% more or 50% more, or maybe 100% more, because unreported data we did not have this. This is what is the reported data. So look at this month-wise distribution of lumpy skin disease. This is based on the 3 years data we had. And as I said earlier, it is a vector-borne disease, and vectors abundance is after the monsoon period starts. From the 7th month onward, जुलाई अगस्त के बाद चलेगी disease और दिसंबर जनवरी तक रहती है. This is आपको ये तीनों साल का दिखा रखा है. First week again it was somewhere in August. Second peak, third, fourth. सभी जो peaks हैं उसी period में आ रही हैं. What does this say? ये disease आज के दिन में हमें cases मिल नहीं रहे हैं. Although we have now starting observing some cases. अभी I got some reports from Rajasthan. There were few cases, confirmed cases. Then Maharashtra, Aurangabad district, Rajasthan, Ganganagar district. This disease is re-emerging. So what does this indicates? कि आपको यहाँ पर कुछ टाइम के लिए ब्रेक मिला हुआ है. नेक्स्ट मानसून के बाद दोबारा से पीक आ सकती है. This is what the inputs we gave to the Department of Animal Husbandry during Government of India. So we advised them, go for booster vaccination now. No, now. We gave them, we made the zones. In some zones, monsoon starts early. For example, Karnataka, Andhra, you will be having, we gave them zones. We gave them 15 days window. कि अप्रैल के 15 days में इस जोन में करिए, फिर उसके बाद दूसरे जोन में करिए. Till we have given them the plan, and they have already approved it, and they are now implementing. So this is where the role, I say, this data plays, and the role the institutes like Nivedi play in giving the inputs for taking the control measures. We are not directly involved in controlling the disease, but as the epidemiology definition says, we give the feedback or inputs to our stakeholders so that they can take the control measures. So based on this, this slide itself, Government of India decided we go for the booster vaccination, and they have started it. So as I said, we are working on different parameters, even climatic variables also associated with lumpy skin disease. And then we work out the disease hot zones, hot spots, or cold spots, or the risk maps, disease maps, everything we are doing for 13 diseases. Now we have added 2 more diseases to that. Lumpy skin disease is one of them. So we prepare how many cases are there, and how many, and we have the information in each village how many cases of lumpy skin disease were reported. In each district, how much cases were reported. So that kind of data. This kind of information is very important for policymakers. So coming to the Karnataka example, I said, as somebody was saying, the control measures का क्या role होता है. So Karnataka, they started vaccination. Their vaccination focus was here and south of Karnataka. ये जो middle वाला portion है ना, यहाँ पे उन्होंने vaccination implementation नहीं किया. So 2022, this slide is showing data from August to December 22. So this was something. This is called Belgaum or Belagavi, and this is called Ballari. These were the 2 main hot spots for lumpy skin disease. यहाँ पर maximum mortality हो रही थी, maximum cases हो रहे थे. Reason कि ये जो central कर्नाटका था, यहाँ पर जब गवर्नमेंट ऑफ इंडिया के अलर्ट आने के बाद भी वैक्सीनेशन डिले हो गया because of the non-availability of requisite number of vaccines or whatever reasons. So this is, whereas these areas, यहाँ पे vaccination हो चुकी थी, तो यहाँ पे disease कम आई. And you see, for Karnataka में, this is a reproductive number R0, you know now. Everybody lumpy COVID-19 has shown what is called R0. R0 means one animal, how much animals it will be capable of spreading the disease. So if it is more than one, mean the disease is likely to be persisting in the population. So R naught during August was very high, more than 3, 4, something like that. And then there was one peak in August. Then second peak comes somewhere in November, December, November. Then December there was another peak. So it indicates that disease is still there, virus is still there. Another peaks can come and it can spread. And one part I said, we are also working on the economic burden of diseases. Lumpy skin disease, we started working this year from last 4 or 5 months, we are working on that. And we found that how much the burden of lumpy skin disease to the country. We have already done the data collection from 3, 4 states, Karnataka, Maharashtra, Gujarat, Rajasthan. This is the table showing the analysis of the data from Rajasthan. राजस्थान को लंपी स्किन डिसीज के कारण 2500 करोड़ का मिनिमम नुकसान हुआ है. लॉस इन द फॉर्म ऑफ मिल्क लॉस फॉर कैटल 5800 rupees, mortality loss 16,500 rupees, treatment cost, opportunity cost of labor, and so 27,001 animal loss. Group, when we are keeping animals in crossbred, if it is animal, indigenous animal, 27,000. If it is crossbred animals, they are more expensive and they are more milk reduction to 49,000. So overall, we are finding that 2,500 crores rupees Karnataka alone में हुआ. So if you work out the entire country's data, economic burden कितना रहा है, और ये data के कारण ही जब हम ये data सरकार को देते हैं, तो they are able to decide based on that कि इसकी हमें फ्री ऑफ कॉस्ट वैक्सीनेशन करना चाहिए. नेशनल एनिमल डिसीज कंट्रोल प्रोग्राम के अंदर में फ्री वैक्सीनेशन कर रहे हैं. दिस इज व्हाई दे हैव डिसाइडेड कि 23 and 24 2 years we will be giving booster vaccination because it is causing the economic burden. उनको ये फिगर सही होते हैं. So coming to the conclusion of lumpy skin disease, challenges and prevention and control. We had one challenge, there was no availability of vaccine, as I said. Goat pox vaccine ke upar shift karna pada. Now we have the homologous vaccine also. Then we did not have the information on if we are using goat pox vaccination, does it need booster vaccination or not? So we have now got the data, serum samples collect करके देख लिया कि अगर ये, और field epidemiological data also we collected. Those animals which were vaccinated 6 months back or earlier than that, उनमें डिसीज रिकरेंस भी होने की चांसेस हैं. कुछ केसेस हमने ऐसे रिपोर्ट किए. सो बेस्ड ऑन दिस इंफॉर्मेशन we decided कि let us go for booster vaccination and timing of vaccination also based on the as I said, हमने एक पूरा टाइम शेड्यूल एंड वैक्सीनेशन प्लान बना के दिया है कि मानसून से पहले पहले किस किस जोन में कहाँ कहाँ कब होना है. दैट इज इंपॉर्टेंट थिंग. देन पोस्ट वैक्सीनेशन इम्यूनिटी मॉनिटरिंग. नाउ इट इज इंपॉर्टेंट that every year we should be monitoring vaccination status, and based on that monitoring we should be deciding कि आपको कब booster लगना है, कब तक लगना है. And so post vaccination surveillance is important because now we have started thinking on eradicating lumpy skin disease. तो इसके लिए हमें systematic scientific data generate करना है by syndromic surveillance of clinical science, serological surveillance, and also we need to develop assays which can differentiate between infected and vaccinated animals. So this is another opportunity where NIAB can also play a role. Then we should be doing virological surveillance, environmental surveillance, environment में virus कितना है, load है भी कि नहीं, और vector surveillance. Then we have to have the plan, exit plan. Exit plan means when we will be able to declare the disease is not in the country. Eradication of the disease, it has been eradicated. So exit plan के लिए भी आज से ही काम करना है. So vector control के different measures हैं, biosafety and biosecurity. This is one area which had the consequences of spread of lumpy skin disease because we did not take biosecurity measures when the first case was reported. So exit strategy, we have already made for that. We are targeting that lumpy skin LSD freedom by 2030. And for that, annual vaccination already recommended that we have to go for 3 years vaccination, and government of India is agreeing to that. And then we'll be stopping the vaccination and doing this surveillance. Surveillance will be doing continuously for 3 years after the stopping of vaccination. We'll be doing both clinical surveillance, because lumpy skin disease is visible clinically. Lumps देख के पता चल जाएगा एलर्जी है या नहीं. Although some cases cowpox, buffalo pox needs a differentiation, and no disease for 2 years after vaccination is stopped with clinical, virological, and serological evidence. So these activities have to be done in the entire country basis to say that India is free of lumpy skin disease. So you look at the scale and magnitude of this labor and efforts required for doing this activity when there are 300 million cattle spread over the entire state of 29 states. Yes. Yes. That is why this important ना surveillance. ये इरेडिकेशन इंपॉर्टेंट इसलिए होता है कि ट्रेड इन्वॉल्व है. हमारा मिल्क है, वी आर द लार्जेस्ट प्रोड्यूसर ऑफ मिल्क, और अभी हम एक्सपोर्ट करना चाहते हैं मिल्क को. कैटल भी एक्सपोर्ट होता है, लाइव स्टॉक भी एक्सपोर्ट होता है, लाइव स्टॉक प्रोडक्ट्स एक्सपोर्ट होते हैं. वो सारे हैम्पर्ड हो जाते हैं अनलेस वी हैव दिस इरेडिकेशन सर्टिफिकेट. तो दोबारा आएगी तो सर्वेलेंस चल रहे हैं हमारे कंटिन्यूअस. उस वंस डिसीज इज इरेडिकेटेड, उसके बाद फिर क्या होता है, जब फर्स्ट केस आता है 1 किलोमीटर एरिया बन जाता है. उस 1 किलोमीटर एरिया के अंदर जो भी आपको 100% एनिमल्स को मॉनिटर करना है. कोई भी केस आता है उसको या तो गाय के लिए तो मार नहीं सकते, बट अदर डिसीज लाइक अफ्रीकन स्वाइन फीवर बात करूंगा मैं, उसमें सारे के सारे कल करने पड़ते हैं. या मुर्गी में जैसे हम करते हैं, बर्ड फ्लू आता है तो वी कल ऑल दिस. देन 10 किलोमीटर के अंदर पूरा सर्वेलेंस कंटिन्यूस चलेगा. तो वो एक्टिविटी रहती है पार्ट ऑफ अफ्रीकन स्वाइन फीवर में. एक स्लाइड दिखाऊंगा शायद मैं इसकी. नेचुरल में जो गोट पॉक्स का डाटा हमारे पास है, गोट में जब गोट पॉक्स की वैक्सीन लगाते हैं तो 3 साल तक उसकी प्रोटेक्शन रहती है. तो गोट पॉक्स को कहते हैं कि गोट की लाइफ भी 3 साल के करीब होती है. तो वो कहते हैं कि सिंगल शॉट लाइफ टाइम इज गुड इनफ. बट लंपी स्किन डिसीज, क्योंकि लंपी स्किन डिसीज की हमने होमोलोगस वैक्सीन नहीं लगाई है, वी हैव पुट द गोट पॉक्स वैक्सीन. हमने टेस्ट किया है इसका, सीरोलॉजिकल सर्वेलेंस वी हैव डन based on the 2020-21 sampling we are doing. महाराष्ट्र में हमारी एक स्टडी चल रही है. उनका जब वैक्सीनेशन के बाद रेगुलरली एवरी मंथ दे आर सेंडिंग अस सैंपल. हमने सैम्पलिंग प्लान दिया हुआ है, उसके बेसिस पे सैंपल आ रहे हैं, और हमें 8 महीने हो गए हैं, अभी तक इम्यूनिटी है उसमें. तो दिस इज व्हाट इज, जो आप क्वेश्चन कर रहे हैं वो हम कर रहे हैं उस पर काम. दैट इज फॉर गोट पॉक्स. अभी हमने LSD वैक्सीन क्यों लगाया नहीं है, कुछ एक्सपेरिमेंटल एनिमल्स में हमने, व्हेन आई वाज वर्किंग एट NRC क्वाइन, हमने वो एक्सपेरिमेंटल वैक्सीन बनाई थी, 27,000 एनिमल्स में लगाई. वो 27,000 जिस एनिमल्स में लगाई उसमें किसी एक में डिसीज नहीं आई थी, और उनको हम पोस्ट वैक्सीनेशन इम्यूनिटी हमने उनका 45 डेज तक ऑब्जर्व किया था. There are mathematical calculations also, and then VNT का titer होता है, titer something about 32 or so in virus neutralization. That is already published data. तो उसमें इतना titer immunity है, तो that means it is giving protection. So post vaccination you collect serum samples at different stages, go for VNT, and then there is a scope we can develop assays other than VNTs. उसके टाइटर एलाइजा टाइटर्स के बेसिस पे हम कर सकते हैं स्टडीज. तो दैट इज व्हाई से देयर आर एंडलेस अपॉर्चुनिटीज टू वर्क ऑन दिस डिजीज. सो इफ यू वांट आई कैन टॉक ऑफ ASF इफ टाइम परमिट्स. आई हैव, या चलो मैं 5 मिनट में खत्म करता हूँ इसको जल्दी से. सो अफ्रीकन स्वाइन फीवर इज अगेन लाइक लंपी स्किन डिसीज. इट केम इन इंडिया समवेयर इन 2020, एंड देन अगेन we have to इसके जो ग्रो, इट इज वन ऑफ द डिसीज इन पिग्स वेयर 100% मोर्टेलिटी होता है, 100% मोर्टेलिटी. So this is a threat. Arunachal and Assam. Pig is there are about 9 million pigs in India, and most of them are in the northeastern states. 40% or more than that are in the northeastern states. Assam, Arunachal, Meghalaya, all those areas. Pig में और अरुणाचल और असम में ही फर्स्ट टाइम रिपोर्ट हुआ था डिसीज 2020 में. So again, if you talk of the African swine fever, this is again a DNA virus, and wild boar are the main source of this virus. African swine, as the name suggests, came from Africa. पहले नहीं होती थी इंडिया में, फर्स्ट टाइम 2020 में आया. All age groups and sex of the pigs, domestic pigs, are affected by disease, and 100% mortality. 100% mortality. Then agent, African swine virus, very stable virus, और कई environment जग में रहता है, vectors भी involved हैं इसमें, और it is, and one more important, there are 24 genotypes. Fortunately, outside Africa, only one genotype, genotype 2 is reported, or serotype 2 is reported, and can survive in environment for months, and can even survive in urine and feces up to 15 days. Soft ticks are the vectors of this virus, Ornithodorus species. And there are 24 genotypes. Only genotype 2, these black spots, they are all Indian isolates. Genotype 2 has been reported from India. Transmission, again, very complex mechanism. Pig to pig transmission, it occurs, and it varies. Their reproductive number, R naught values varies from strains like 1.453 for Georgia strain, Malta strain up to 18. So they're fast transmission. So African swine fever strains also vary in their transmission rates. Pig to pig transmission also occurs. Wild boar to pig transmission is very common. Fomites, the equipments, the vehicles, they also transmit the virus, and it remains in the infected blood, high titer for many days. Nasal fluid में भी virus होता है, and it can be transmitted through oral route, through nasal, respiratory route, and feces में भी कई दिन तक virus रहता है, urine में भी रहता है. So ticks, they carry virus for. So there are so many niches for the virus to survive, and there is no vaccine available for African swine. It is not a zoonotic disease, and there is no vaccine available for African swine. So that is a big challenge. People are working on vaccine, but till day we don't have. So how we can control this disease? Only biosecurity. Only biosecurity. So we have to cordon off the farms. We have to take the biosecurity measures. और जहाँ से transmission के मैंने बताए हैं ये रास्ते, इन सब में कहीं ना कहीं biosecurity measures लेने पड़ेंगे. So African swine fever, it came from Africa to Republic of Georgia 2007, and then India it reached in 2020. Surveillance, what we are doing? We are doing both serological surveillance, virological surveillance, and epidemiological surveillance. Serological assays भी हैं, PCR, virological करते हैं, real time और PCR that we are doing regularly, and then molecular biological surveillance भी कर रहे हैं कि genotypes के अंदर क्या क्या variation आ रही है, that kind of things also we are doing. Why do you say it is difficult? No, it is, handling pig is little difficult, but trained people are doing that. They live in dirty places, कीचड़ में मिलेंगे, आपको डर लगेगा उसको हाथ लगाते हुए. That's true. But the trained people are doing that. And then you go to slaughterhouses also, if you have that kind of problem. More. Yes, that's true. Yeah. Then African swine fever started in Arunachal, Assam, and now it has spread way down to Kerala, Karnataka. 16 states are affected. 123 districts affected. This is based on the what case reports we have got. 26,021 pigs confirmed to be African swine fever infected, and out of this 26,000, 21,835 dead. Means 84%. So I said mortality up to 100%. So how lethal this disease is, and there is no control. This one disease has devastated the entire pig sector in the country. So coming to the prevention, when there is no vaccine, what should we do? Should we keep on sitting or take some measure? We can have some like this kind. We were talking of the infected zones. 1 किलोमीटर के जोन में जितने भी पिग हैं वो कल करिए और 10 किलोमीटर का एरिया में सर्वेलेंस करिए and implement the biosecurity measures. Then in general I am saying last slide probably prevention at the entry point. जो भी port of entry है चाहे एयरपोर्ट से चाहे रोड से चाहे रेल से चाहे सी से दूसरे कंट्री से जो भी डिजीज आनी है वहां पे कहीं ना कहीं चेक पॉइंट हो वहां पे सर्वेलेंस हो कुछ ना कुछ डेटा वेटनरी और इंटरवेंशंस हो ताकि such events do not occur or they are immediately reported. Then stringent quarantine measures in the country wherever disease is occurring. Then prevention of further spread to the other district states by movement restrictions, animal checkpost, health vaccination, and then early detection using rapid and sensitive diagnosis. अभी हमारे पास ये नहीं है आपके लिए point to think on that African swine fever. If you want to work on that, आप लोगों की I know you work on very this rapid diagnostic assays, LFAs kind of thing. So this is one area if you are interested. Then outbreak investigations, and we should have rapid response teams at state level, district level, local level, ताकि ये बीमारी ना फैले. So African swine fever again came from these roots. So with that, I thank you for giving me the opportunity, Madam Director, Madam and Dr. Karu Sharma ji. I am obliged that you gave me this opportunity on this auspicious day. Thank you very much.
Reporting accuracy. But sometimes over reporting हो जाती है international में compulsion दे दिया तो एक कैटल मरेगी फ्लोर पर मरेगा सारी जाने तो आपने उसमें क्या हुआ उनका थर्ड डे रिपोर्टिंग कंसिस्टेंट थी कोई भी कैटल मरेगी कंसिस्टेंट तो in साइंटिफिक वाइज से करना अपनी हमारी one thing is there for the years right to 80% of cattle in the country. So already all the buffaloes so modified workers मोबाइल जो भी उनको ओपीडी मेडिसिन चलेगा कोई भी केस आएगा आपको रिपोर्ट करना है उसमें जो हमें केस करने के लिए है मेरा कारण वो ठीक कर उनको घर को वो ठीक करना है कि ऐसा सही नहीं है वो है तो कितना है इसमें क्या नाम है बढ़िया है या मीटिंग है या सिम्टम्स भी हमें नहीं तो प्रॉब्लम है तो दे हैव टू डू इट फॉर एवरी तो एवरी वो सब डिस्कस करने का फर्क नहीं होता है जिसमें सिंड्रोम टेक्नोलॉजी हाई है इसको कम्युनिटी इसको अगर इसकी ये प्रमोट हो इसकी का हमारे क्लाउड क्लाउड सिस्टम तो इस रियल टाइम इसमें किसी को इंसेंटिव नहीं है जॉब को मैनेज आपको उसमें भी करनी ही है तो वो रिपोर्टिंग होनी पड़ेगा चाहिए पहले कि जब फूल हम सर्विस की बात कर रहे हैं तो वायरस इंडिविजुअल हम कहते हैं कि आप एक से पाँच रुपये नो और इंसेंटिव मैनेजमेंट का जो मैंने आपको एग्जाम्पल सुनाता हूँ तो वो रिपोर्टिंग मैंने आपको बताया था ना कि कीप ऑन वैलिडेटिंग भी गया कीप ऑन वैलिडेटिंग मेरी प्रेडिक्शन फॉर एग्जांपल इन अप्रैल आई मेड प्रेडिक्शन फॉर द मंथ ऑफ जून अप्रैल में जो हमने जून में किया जून का भी ना जरूर वैलिडेटिंग वो वैलिडेटिंग में हमें लगता है कि हमारी प्रेडिक्शन है 90% और 80 to 90% वो ये प्रेडिक्शन जो हम कर रहे हैं वो रिस्क की प्रेडिक्शन है वी आर सेइंग देयर इज रिस्क ऑफ say for example HSPA का रिस्क कितना है risk is not कि disease होगी this is the amount of risk based on all the inputs we are getting and how much that risk turns out into the disease outbreak वो हम data से validation करते हैं every intermediate month will be getting data of clear to be valid.
Sir, I have one question. So this is regarding brucellosis. So you mentioned that we have we have but we have no plan.
जो वैक्सीनेशन करते हैं वो ऑलरेडी surveillance of sheep and goat and pigs we are doing.
So is there any
लॉन्ग टाइम टेकिंग वो आजकल उसके पूरे काम कर रहे हैं क्या बना रहे हैं कि जब भी ऐसे कोई रिक्वायरमेंट आए वैक्सीनेशन अप्रूवल आपने कोई वैक्सीन बनाई है उसको अप्रूवल से ऑनलाइन हो जाए और आपको विद टाइम फ्रेम अप्रूवल मिले तो ऐसे सालों साल तो थैंक यू वेरी मच
all the employees and also very good lecture. And like lots of discussion can happen on this topic. Because most of us are the topic is so touchy that everyone has some kind of sentiment associated with that. So in future also we will be getting some guidance from you. And thank you very much for so we will have a